This is just a video of some of the stuff I got for Christmas. Fuji Electric 2-pole 5 ampere breaker. 5 ampere / 30 milliampere trip ground fault interrupter. Some of these weird intended for mounting on a backplane switch light breakers. These are 6 ampere, 15 ampere, and 10 ampere. All made in the mid 1980s. This is 1980s. This is, I don't know, it doesn't say. These are some Allen Bradley DC rated DIN rail mount breakers. Want to see about getting some DIN rail stock from a neighbor. Then I got some Square D QO breakers, which are suitable for DC use. And one good thing about these is they've got a little window that, if you can see it there, that's a little red thing that flips down so that it tells you when the breaker's tripped. This one has this weird thing where it's got this kind of a detent in the middle where it'll stop if it trips. And some of them, and some breakers, that can be hard to see because they've got really stubby handles and it's very hard to see where they're in the trip position. And then when you flip this off, there's a little position here where when it's off, you need to push it down, and then you can reset it. So, but then again, made in Japan, and Japs are weird. You can see we've got instructions on the side that say how to reset it. Although how you're going to read that when it's in a backplane and there's a whole bunch of missile wiring and. But then again, Japs are weird. If you have any objection to my using the term Jap, look up the term Unit 731 for more than you ever wanted to know about Jap atrocities during World War II. And I got some of these Matsushita metal oxide varistors. These particular ones are 436 volt trip. Those are the active component in a surge protector, so the little thingamajig has a little, that's pretty much what's in a surge protector to shunt any kind of potential surges or anything. And the way these typically work is they have these wired in a series with a fuse, and then there's a little idiot light wired across the varistor, because when these are hit with a big surge, they usually fail short, which will blow the fuse and turn the light off. So that little light that tells you to replace it, to replace the device if it goes out, that's how they work. Although the problem is that if they're exposed to a number of surges, they can fail. If they're exposed to a number of smaller surges, they can fail open. So that light will never work as an indicator in that eventuality. And then I've got some 3156 automotive lamps. Some little, these are G8 7-watt lamps. A Type 105 lamp. These are all 12-volt vehicle signaling lights. And I've got a, these two are, I think, 1093s. These ones are 199s. Are all 12 volts or 12 volts and change. Then I got a pair of Type 1383 13-volt 20-watt reflector lamps. Are often used for elevator interior illumination and passenger reading lights in vehicles. Then I got some 10-watt 12-volt S14 sign lamps. Some 75-watt A21 12-volt lamps. Some blue 25-watt lamps. Some little from Sylvania LED. Supposed to replace S14 lamps. These are something that bulbs.com has had sale on for a while for $1.99 each. So I got a couple because they run cool and you can actually use them inside in like mini LED lamps. This is a lamp I've had for some time, but I actually got a GU10 base for it. This was at Home Cheapo, the last of the American-made Lighting Science LED lamp, so I got it. Probably going to mount the handle on this and turn a little inspection light for stuff. This is just a lamp holder that I already had for the 3156s. I got some 917 T5 wedge base lamps, and a 25 watt, 150 watt A25/PS25 lamp. The thing with that is that they're often called PS25, but they have A25 envelopes, so weird. Let's see, that's... Oh, then I got this Eaton motor control switch with these interesting shrouded contacts. That was a PT surplus find. Likewise, I got these 24,300 ohm Israeli-made Vishay resistors. Oh, they're also marked Dale. Although what's interesting with these is that the rating on it is written. It isn't in colored stripes the way normal resistors like these are. These are some 464,000 ohm, 1% tolerance Brazilian-made Philips resistors, and this is just a little reel of 5,000. So yeah, if I've ever did a bunch of those, got it. This is, in comparison, this is only 1,000 of them. This is, although these are 100 nanofarad capacitors. They're Corning Glassworks, or specifically their electronic products division. That's who made them. Then I got some of these S11 7.5 watt nightlight lamps, some 6S6 155 volt indicator lamps. That oddball potential is largely intended for life extension on 120 volt use. These are 4 watt 120 volt CEC Industries T4 candelabra based lamps. These I got for that Arrowheart switch I covered in a previous video. And what else? Then I got this interesting Scylla Z European fuse. I don't know what I'm going to do with it though, because I don't have any things for it. You can compare it to this Fuji electric fuse, which I can't find any information on whatsoever. Although it is definitely not one of these Neo-Z/Dia-Z type European fuses, because the trip indication pin is on this weird one. It's on the narrow end, whereas on the Scylla Z one, it's on the wide end. So you can see that's how it mounts in the holder. Obviously intended for installation equipment where you would not be able to get to this while it was live, because if you disconnect this while the fuse is in there, it's live, and if you take that out, that's live, and yeah, again, made in Japan, so weird. Then I've got some British-made little fuse. These are these little tiny 197mm by 787mm little tiny fuses, but I know people who have stuff that use them, so dinky little things compared to our equivalent of this, which is 1 1/4 inch by 1/4 inch, or those big things, big fuses. But anyways, then I got this very old, probably at least 80 years old lamp holder thingamajig. There was a cork on this threaded shaft, so I think this was intended for sticking in a wine bottle or something and turning that into an ad hoc light fixture. Because the original cord on this, although this is, I think, either polyethylene or nylon insulated SPT cable, it was cloth covered rubber conductors, and then there was a cloth overwrap. So I'm guessing probably from at latest the 1930s. And then the inside bit of it is ceramic, whereas I have some ones that were made in the early 1940s during World War II, and those, the outer casing is aluminum, because that was done during the war to save on copper. And those, the interior is, I think, Bakelite, or at least the insulating material that the switch is made of. Although I think the it's marked Hubble, although it's Hubble. This is, I think, either hard rubber or Bakelite. It doesn't feel like Bakelite, though, so I think this might be hard rubber. So this is probably something from the 1920s or thereabouts. Oh, and that arrow heart thing, if you hadn't seen the video, this is what I'm talking about. Just happened to be lying under there. And then what other cool stuff? Let's see. Got some IRF 9540 MOSFETs. I got a Velleman K8071 power LED driver. Some 1N5822 Schottky rectifiers. These are some much bigger Schottky rectifiers. These are Q220 package, and they've got this weird 2-pin thing. Although that's because they're a diode and they only need 2 pins. Whereas transistors and potential regulators and stuff, they have 3 pins, but that's because they need 3 pins. Then I've got some, what are these? 23904, typical NPN BJTs. These are 78L05, 100 milliampere maximum current, 5 volt potential regulators. And then these are 7805 potential regulators. Those are the 1 ampere version of the 78L05. And these are 78L12. Those are 12 volt 100 milliampere potential regulators. 115 ohm 5 watt power resistors. 1 nanofarad ceramic capacitors. That's 100 of them. And then somewhere in here are some 78S40 potential converter driver chips, I think. And then I've got some LM393 printer comparators and some LM358 operational amplifiers. This is just a reference circuit for the 78S40 potential converter driver. That is, yeah, these are the 78S40s. These are really hard to find chip nowadays because they're obsolete. These were $1.55 each for, doesn't look like much, but they're very hard to find. These are the older version of the MC34063 potential comparator, which is just a stripped down one of these. No integrated rectifier diode, no integrated uncommitted operational amplifier, because these also have an uncommitted operational amplifier that is independently powered. That's interesting. Might incorporate that into a low potential shutoff in this, just to make use of it. But this is a reference circuit I found. Some guy made one of these to use as a supply for glow plugs for model aircraft engines, because many of them have little 1.5 volt glow plugs to bring the engine up to a temperature. And it was proving to be too much of a hassle for using nickel cadmium cells or something, so he came up with this. It does one thing is that it does say that it uses a 10 ampere diode, and the 2-pin ones that I got are 7.5 amperes. But I'm not going to be needing this at anything close to the current that he mentions of, which is 4 amperes continuous. So, because this is just going to be for powering things like 1.5 volt or 2.5 volt little precision optics type lamps. So, and then I got some miscellaneous quality super bright LEDs and solder paste, which is always useful, and other than that, nothing fancy, just stuff, like practical stuff, but then again, that's the kind of stuff I get for Christmas. You know, this crap.